CloudDB, shaping your new normal.
Hey, let's make a start. Welcome to the Efficient Data Handling Techniques in Python for Oracle Database session. My name is Christopher Jones. I'm here with my colleague Sharad. I'm going to talk to you about how to make your Python applications really fly and available with Oracle Database. Just got a few slides to warm up. Most of what we'll do is code. This is the overall architecture for where our group sits. We look after all of the database access APIs. And in particular, Sharad and I look after anything which sits on top of that C language API itself. Today, we're obviously going to be talking about Python CX Oracle. One quick architecture slide. CX Oracle is the Python database API compliant interface. A little asterisk there. There's one or two omissions where Oracle Database doesn't have a feature, but there are lots of additions for fantastic things such as AQ and CQA and a two-phase commit and all sorts of things. It is a thick client API, so it sits on top of the Oracle client libraries you can see in the bottom of that middle box. And it talks obviously across SQLnet, so it can take advantage of all the SQLnet features such as encryption and talk to the database. Those thick client libraries give us a lot of functionality for free, all of the high availability stuff, for example. CX Oracle is the most downloaded of all of our APIs, 2.5 million or so downloads a month at the moment and growing. It's widely used from everything from system administration to data analysis. It's available in Pandas, SQL Alchemy, Django. Obviously, it can be used with lightweight frameworks such as Flask. So it's highly available, highly popular, growing user base. And the final slide before we get to demos, just to give you an overview, I'm going to be talking about connecting, which is always a hot topic. Everybody wants connections to be highly available. Then we're going to go and talk about fetching and loading data. And as promised by the abstract, just talk a little bit about availability, in particular about application continuity and CX Oracle. So let's run some code. Sharad, where are we?
Okay, so what we have here, Chris, is a Python Jupyter notebook. So in Python Jupyter notebook, you can run through code step by step and then explain what each code does. You can have also have some of explanation notes like you see over here to explain what each code does and what are the prerequisites that you need to do before you run a code. So before we jump in to connecting to an Oracle database, we have to take care of a few installation requirements. As you can see there, we have a document reference for what we need to do to install. So in CX Oracle, first you need to make sure that you install CX Oracle package and the Oracle client libraries, as indicated by our earlier slides. The latest stable version of CX Oracle is usually available in the Python package installer PyPy repository. You can get it from the PyPy repository by using the pip command to download to your local machine, which can be on any platform. Similarly, you have to install the Oracle client from the www.oracle.com webpage. And or if you're on Linux, then you also have the alternative option of installing both CX Oracle and instant client RPM packages from the yum repository. Now that all the installation is done, we'll look at how to initialize the Oracle client libraries. Now, any app accessing the Oracle database will need to know where the Oracle client libraries are so that it can load them. There are many ways to do this. The most common way, or the just let me scroll it down a bit. The most common way is to set the Oracle client libraries in app. So quickly running the code here. As you can see, if you're primarily using a Windows platform or a macOS platform, you can set the Oracle client libraries using the init Oracle client function and the libdir attribute, which will point to the client libraries directory or folder. But on Linux, this in-app method will not work. You will have to set the Oracle client libraries before the app starts. For Linux, you can do that by using the ld config utility, or you can set the ld library environment variable path in the Linux in your Linux machine. So one more tip is that if you do not want to go through this trouble, you can always download Linux RPMs from the yum repository, which will save you the trouble of running the ld config. let's move on to now that we have initialized the Oracle libraries, we can connect to a database. So the connections are used for executing SQL, PLSQL, and SODA, which is Oracle's native document store API. So all SODA calls also used for executing SODA calls in an Oracle database. So quickly, let me set the credentials here to connect to the database. So one quick tip here. So here we are hard coding the password, but it is always recommended that in a normal runtime environment, you have a much more secure way of setting the password. You can prompt for a value, you can pass it as an environment variable, or you can use an external authentication method for Oracle like Kerberos or even a wallet. So there are many ways to connect to the Oracle database. The easiest way is to use the EC connect syntax, in which you have to specify the host name and the service name, like we have done here. So you once you set it, you get the connection object back. The advantage of using the EC connect syntax is that you don't have to configure the network configuration files of Oracle database, and you can, as long as you have the service name and the host name of any Oracle DB, you can plug and play those values into your app. So another advantage as well, which you have introduced in 19C, is that you can add parameters like connect timeout and expire time, which can be used to avoid your firewall timeouts or any other connection timeouts also, and other parameters also. Moving on to the connection types. So far the connections that you've seen is a standalone connection, but the problem with a standalone connection is that it is very expensive to scale, and each time you set up a connection, you have to wake up the listener, you have to set up the DB server process, and then you have to wake up, or you have to make sure that all the resources are in place for each single connection. And this will end up taking a lot of time. So most of the applications use pooled connections, and this pool and the connection pool will last for the entire lifetime of the application. And you have to use a pool if you need a lot of connections concurrently for short periods of time, and if you have a small number of connections that are often idle. Also, just a side information here. So your connections and your connection pools will support most of the advanced features of Oracle, such as DRCP, application continuity, fast application notifications, etc., which we'll talk about or at least touch upon later during this session. So quickly running the pool connection. For running the pool connection, you have the session pool function of CX Oracle, and once your pool is created, you can acquire a connection from the pool, and then you can do something useful with the connection that you get. So some more information is that you have, for the pool, you have their growth parameters like min, max, and increment. So this is used to determine the growth rate of the dynamically sized pool. But the general recommendation from the Oracle performance team is that if you require a really stable environment where you don't want any connection storms, or we want to reduce it, it's better to use a fixed pool. So to set a fixed pool, you have to set the min parameter equal to the max parameter and set the increment parameter equal to 0. Now, talking about efficient, we always are looking for efficiencies in our code, efficiencies in our application. So one of the key parameters to judge the efficiency or optimization of your application is to talk about round trips and how to reduce them. So round trips are basically the trip from the client to server and back when you're fetching data or when you're doing data processing. There are a lot of ways by which you can reduce these round trips and increase your performance and scalability. So one of the ways is to optimize the way you set the session state. For that, Chris, I put it to you.
Yeah, sure. Thanks, Sharad. So we often see people try and set some session state after they create a connection. And you can see here, get a connection with a pool.acquire, and 2 executes 2 extra round trips to set some session state. Now, this is a standard thing, often needed. But if you're using a session pool, you can, as we show down below, optimize things by using the session callback parameter to, when you create the session pool, pass in the name of the function which you've created. And this function gets called before any pool.acquire returns a brand new connection. And the key thing is that it only needs to be called once per connection in the pool, because pools retain that session state. Connections in the pool retain that session state even when you've closed or returned the connection back to the pool. So there's great efficiency there. Instead of having to do, as you see up above, alter statement every time you do the pool.acquire, here you don't even need to do anything in your application code. It can all be hidden away. And you can guarantee that this pool.acquire, the connection which gets returned, has this session state. Again, this only needs to be called once per connection in the pool. And we can kind of see that in this example below, where we have pool max is 4. And this is a little sort of dummy example. Pretend you have a little web service, 1,000 user requests come in. So you've got 1,000 connection requests needed, maybe the 1,000 alter calls to set some session state. The app may do 1,000 SQL queries. And therefore you've got 1,000 plus 1,000 equals 2,000 database calls. But if you use the second method with the callback, then you only need to do that alter call once per connection, which is in the pool. And you've halved the database load in this case by reducing the number of round trips to the database, by reducing the amount of work that the database needs to do. So this is a very efficient way to set state. I should note that transaction state, so anything you've inserted, updated, etc., will be rolled back when the connection is closed, and the with block that automatically happens at the end of the with block. The connection will be closed from the application point of view, returned to the pool from the pool point of view. Connection transaction state is cleared, but this session state, package state is retained, and that's what the init session function can do, and therefore very efficiently set that session state for your applications. Sharad, why don't we just move on to the next section? Over to you.
Yeah, thank you. Thanks for that explanation, Chris. Now we have a new notebook here. So let's look at fetching data now. Before that, let me set the connections. Again, because it's a new notebook. Okay, now that we have set the connections, we look at the ways in which you can fetch data using the connections. There are actually 3 ways that are shown here in this example. The very first way is to fetch a single row of data from the query. So you use fetch one. You use fetch one method to fetch a single row of data, and then if you want to fetch a bunch of rows or all rows from a small table which is not too big, you can use the fetch all method. And as you can see over here, all these 7 rows of this table is being selected. And for instance, if you have a very big table and you don't know the number of rows that it will return, it's always advised to use the fetch many command, which will fetch the rows as a batch. So you will get a batch of rows each time you use fetch many. And all of these fetch methods, the number of rows that they fetch is set by the buffer tuning parameters called prefetch rows and array size, which we'll be talking about shortly.
Yeah, Sharad, shall I talk about that?
Yeah, Chris, why don't you take it? Go ahead.
Okay, so as Sharad mentioned, prefetch rows and array size are tuning parameters. They apply equally to all of those 3 methods Sharad just showed above. One little proviso is the actual batch size that the fetch many gets is actually tied directly to the array size. But internally, other than that use, these are used for sizing buffers, for optimizing fetches of data across the network. So they don't cause the SQL statement itself to execute any better. They don't change the explain plan or anything like that. They're just purely for batching records across the network from the database back to CX Oracle. And this little demo shows we're going to count those round trips. We're getting the session ID so that we can query the appropriate $B table to count the round trips. And if you look a little bit lower, we're going to count round trips before we do some work and after we do some work, and then print out the difference. And that work is just doing a straight select particular number of rows, and we're going to change the various values of prefetch rows and array size. Now we have 2 different values because they affect different layers of the application library, the CX Oracle and the Oracle client libraries. just a kind of fact of life and the way they work. We could spend a lot of time explaining exactly the pros and cons, but the bottom line is these are tuning parameters. They don't affect how rows are returned or how many rows are returned to the application, but they affect performance at the expense of a little bit of memory. Let me run this quickly. I should have run it just before, and we'll skip down to the bottom where it's run, the less appetizing black output. So there are default values, 2 for prefetch rows and 100 for the array size. And you can see, depending on the number of rows we fetch, the round trips obviously increases as you need to fetch more rows. You see roughly, getting 100 rows, 100 to 10,000, give or take a little bit with the prefetch rows value. But the key thing is with the unknown large number of rows, you really want to be bumping up array size, if not also prefetch size. You can see the round trip dramatically reduces when we increase array size. Now, if you have huge numbers of rows, the difference between one extra prefetch round trip here by bumping up prefetch isn't particularly noticeable. So you may just want to leave prefetch as the default size. There is an extra memory copy if you use prefetch rows just for that first batch of records. But your tuning needs to be done in your production environment where you know your actual network speeds, where you know your actual data sizes, the table widths, the number of rows, etc. And that will just determine your actual load on the database will be decreased by increasing array size, and the application performance should definitely increase. So tune those in your production environment. The fun little thing here, as you've probably read ahead, is the paging of rows. Your web page, you want to print page of records. The trick here is to set prefetch rows to 1 greater than the number of records that you want to fetch. And that avoids a round trip end of fetch to check whether any more rows are needed. And as you can see, that's the optimal number of round trips just to fetch these 20 rows. So you've got some tuning parameters. Make sure you use them, usable in large number of situations. We do see a lot of people pumping data backwards and forwards. And certainly for the big cases, you want to increasing array size to whatever memory you can cope with, whatever the network memory buffers can cope with as well. Sharad, where in clauses, something which is dear to my heart. Do you want to talk about that?
Yeah, thank you, Chris. So some of the common question that we get from users today is how will you bind if there are a lot of values which need to be passed to the variant clauses? So here we have a simple example. If the number of values passed into the variant clause is small, or the maximum number of values passed into the variant clause is small and no. So as you can see, all you need to do is to just bind the bind variables to the bind values. We will be talking much more in detail about bind values in the next notebook or the next part. And if you have, let's say, only 3 variables which have proper values, and the other two values, you can set it to none, and you will still be able to bind properly when you are running this query with variant clauses. But what about the situation when you have a huge number of values in the variant clause and when you do not know it beforehand? So ordinarily, the variant clause has a limitation on the number of values that you can pass. It's 1,000. So if you have a huge number of values that you are expecting, then it is always one solution is to use the SQL type, where you create an SQL type object within the database. You can use this type command, type keyword in SQL, and then you can pass this in the query that you're using as a subquery, and you can of course cast it using the table keyword. As you can see, I have taken data value, an array of 3 data values. Of course, you can have a bigger array, and you will still be able to pass it relatively easily. So, anything you want to add here, Chris? Since you want to discuss.
Yes, thanks, Sharad. The key thing I think in number 8 and 9 at the top of the screen is that you're reusing the same SQL statement, and so this has those efficiencies of reusing the SQL statement cache, reusing the cursor. So you don't really want to be just passing in different SQL text with arbitrarily different numbers of bind variables. If you can, just keep the number of bind variable placeholders the same and just assign none to those where you don't have particular values. The other thing about the bottom solution is that it takes a large number of round trips. Working with Oracle objects is interesting, And I think this example takes 7 round trips, whereas the simple examples at the top only take 1 round trip. So you definitely want to use this where it's appropriate, not for every particular case. As well as round trips, you need to be aware that you should check your optimizer plan if you're going to incorporate this kind of methodology in a larger SQL statement, just to make sure it doesn't push something awry with the lack of bind peeking in for the table clause here. If you have very, very large numbers and call the statement a few times, you may see slightly different optimizer plans. So you just want to go and check that as well. Sharad, back to you.
Thank you. Thanks, Chris, for that additional tip. Moving on, let's move on to the next notebook now. Okay, so far we have talked about connecting to a database, how to fetch database. Now let's see how we can work with the data, how to update data, how to insert data, etc. So again, setting the connections quickly. So for this example, I am going to create a new table. So we use, of course, the create table function of SQL to create the table. And the table is created and it's automatically committed. Now I want to talk about binding, which we had touched upon in the previous notebooks. So binding is very, very important, especially for security and performance and scalability purpose. It is especially useful in preventing SQL injection attacks, and binding basically delays the addition of values into the SQL table till the runtime. So instead of having a static SQL, you can have a dynamic set of values inserted when you actually run the SQL. So let me quickly run this example with the bind variables. As you can see, there are 3 types of 3 methods by which you can bind. You can bind by using position, where you simply pass in the value that you want to bind here. It can be in the form of a Python list or a Python tuple. The second way you can bind is bind by name using a dictionary. So you can actually name your bind values that you pass, but keep in mind that the key values for the bind values should be the same as the bind value placeholders that you see over here with the SQL statement. Similarly, you can bind by name using keyword arguments instead of having a Python dictionary. Again, the same rule applies here for now. The keyword argument should have the same name, the bind value placeholder that you see in the SQL state. So this is how you generally do insert for a single row, and how it is always advisable to use a bind variable in case you're passing in data values. So let's talk about batch execution then. When you're trying to insert multiple rows with the same statement, you can, of course, you can use the execute function over a loop and then bind each of those rows, but that is not efficient, and it will take up a lot of the database resources. So instead, what you can do is use the execute many command, where it will bind or it will use an array, and it will and the array will be binded to the SQL function, and it will execute all the multiple rows that you need to insert in one go. So once you've used execute many, let me quickly run the code for you. We have quickly inserted all the 7 rows in one go, and as you can see, we are printing it back. Of course, you can do an explicit rollback, or you would need to do an explicit rollback or an explicit commit in this case to commit it to the database. So we'll move on to talk about execute many versus execute, and what are the performance difference. Over to you, Chris.
Oh yes, thanks again. So this is yet another sort of slightly bigger example. We're going to be doing a little plotting and graphing at the bottom, but effectively we're going to be comparing 2 cases here. Once where we're looping over each row just to do the insert, so we're looping for each row of data and executing insert, and the other case is where we're calling execute many, and that's no lint, just a straightforward single statement. And we're doing this for a number of data values, and I'll run that and plotting, so it's printing at the bottom. Oh, it's finished already, so the plot comes up. So we talked about round trips before, but didn't show data values, but you can get the obvious impression that the reducing round trips by here doing 1,000 round trips for 1,000 execute calls versus 1 round trip with the execute many, it really has reduced round trips, really has reduced the amount of time taken. You can see the plot here. Execute just goes off the charts versus much slower growth for the execute many loop. So even at small values, it can be kind of significant, and always recommended if you're using data. Always recommended if you're inserting lots of data to use execute many. Sharad, do you want to talk a little bit about batch errors with dirty data?
Yeah, so far we have mostly worked with clean data, valid data, but what if you have noisy data or invalid data? So this example shows how you can handle it within the CX Oracle application. So quickly, we have already created this parent table and chain table in our database, and this is the content of these two tables and how they are mapped. The child table, of course, references some columns from the parent table. Now when we want to insert some values into the child table, and let's see what happens. As you can see, you get an error over here. This is because if you see the code, we are inserting some invalid values. What are the invalid values? We are inserting duplicate keys over here, and also we are inserting we are inserting some values which do not exist in the parent table. So if you want your application, CX Oracle application, to recognize these errors, in your execute or execute many command, you would need to set the batch errors to true. And in that case, whenever there is an error, you can use get batch. Whenever there is an error, the error is captured. And if you want to see the error message, you can use the get batch errors function. As you can see, the error the error message is printed out, clearly saying what is the error and clearly mentioning at which offset of the row the error has occurred. So in this case, this offset always starts with number 0. So in this case, offset number 2 and offset number 4, these two rows are invalid rows. So you can now go back and correct these errors and then run the insert statement again to insert proper valid rows. So this is just an execute to show what are the contents of the child table. So one quick thing probably which we may not have added is that there is the auto commit mode which you can use with the execute function or the execute many function. So in auto commit mode, the advantage is that you save a round trip for committing instead of having an explicit commit. But in the case of batch errors, even if you use the auto commit attribute with your execute or execute many, if there are errors, then there will be no commit. You will have to go back, change the error, change the invalid data, and then give an explicit commit. Or if you want to roll back, in this case, you can always roll back. So that is a brief introduction on how we can process and work with data in CX Oracle. Let's move on to the next notebook, Chris. So talk about JSON. So all developers love JSON because it supports dynamic schemas and hence makes schema changes easy. Oracle has introduced the SQL JSON data type as an open standard in 21C. However, earlier versions of Oracle stored and worked with JSON as a log. So one quick tip that we recommend is that you be very careful when you're working with mixed version environments. So again, quickly setting the connection here. Okay, yeah, this is what we talked about. You have to be careful, and there are some examples in CX Oracle GitHub page where we have given some samples on how to work with mixed version environments. So please feel free to go and check that out in your free time. Again, running some cleanup code over here. So let's run this quickly. As you can see, we have created the JSON we have created a table with a JSON database data type column. So this will work. Keep in mind that this will always work only from 21 Oracle DB 21C and Oracle Client 21 version. For older versions, it will throw an error. So we have now inserted the data, JSON data, and as you can see, now we are extracting the JSON data from the specially created table that we have for this demo. Scrolling
Just
down.
point out, I think you somehow managed to run that twice, which is why we get 2 rows, but that's just an artifact.
Okay, sorry. Yeah, so I have run this twice, which is why I'm getting this row 2 times, but that is, you get the general idea, I hope. So just quickly to run this as well. So this is how you can run JSON when you have an older client libraries, which does not support the newly introduced JSON data type. So for this, you have to also run it using output type handler function. Probably Chris, you can explain a little bit more about this.
Yeah. So if we're using the older clients, which we are not here, but pretending we are, when you get data back, you would be getting things as a clob or a blob, and so we use the output type handlers for efficiency in that case. Not necessarily, but obviously you get things directly as a string, as this long string, instead of having to do the clob operations, the call clob methods on a locator. But the bottom line is that you get data back here as the object that you would expect. But take away the point that if you're running in a mixed client-server version environment, trying to do upgrades, you need to be a little bit careful. Obviously, all the databases don't understand the pure JSON data type we created. You have to do JSON and set the storage as blob. That will work in older and new databases, but the older clients won't understand some things like this new JSON data type, which is up here at the top. And then that's why you have to use blobs when you're fetching the data. So it gets a little messy. We'll be over this hump soon. Don't worry too much about it. But you can see that there's some really nice functionality coming up where you can just insert your types, your dicts and things like that, and just get them mapped directly into the JSON stored in the database. Let me run on Sharad and talk a little bit about Soda. So Soda is Oracle's document storage API. It's available in all sorts of places from JDBC, Node, Python, PL SQL, REST. By default, it uses JSON, so it kind of ties in nicely with this JSON, but it doesn't actually have to use JSON. I'm going to be talking about JSON here because that's kind of nice and easy, but you could use it for other things as well. So it's kind of NoSQL style. It's been around for a number of different versions of Oracle, since about 18 or so Oracle, and features getting added all the time. There's a nice little table and document speaking about what features are supported and what versions of the drivers. So in the latest version of CX Oracle 8.0, we have a Soda metadata cache, and this is a cache, so it's going to be good, going to save you time. I'll talk about it in a minute. It's only available with a session pool. And the metadata cache is obviously the description about what the Soda objects look like. So tip 1, use a session pool when you're dealing with Soda and keep up to date because you're going to get this cache in the recent versions of CX Oracle. Soda team like us to enable auto commit. So I think most people are just using documents 1 in, 1 out. As the OCI team, we talked about round trips, so we're a little careful about that. There are some other things you can do to avoid round trips, such as the batch operations similar to the execute menu that we showed before. There's a similar insert menu for Soda as well. But use this as you will. It's there for a purpose. So just running these as I go, I put so that nothing gets displayed. There's this kind of placeholder get Soda database, and we have open collection, create collection syntax, which is kind of useful here in the demo. Some of you may know that create collection actually can be overloaded, and if the collection, in this case, my collection already exists when you run this, it would just be opened instead. I don't rely on that here because for obscure reasons to do that the Soda team can explain, metadata caching works really nicely for open, but not for create. So I want to make use of that metadata cache, and if the cache is populated with details about my collection, an open collection can use that and reduce round trips to the database. So running on, we have a bunch of insert features, functionality. You can see we're just taking here, there's this dict, doing an insert, and we're doing insert 1 and get, and we get some extra metadata, automatically created metadata. In this case, it's the key which comes back. You can, when you create the collection, you can specify some extra options, which I don't have here, about key management, whether it's a sequence or UID, as we see here. A bunch of fetch operations at the bottom. Let me scroll up a little bit. So we have what they call this connection builder. So we have a find, it's kind of a sequence of operators followed by a terminal. And in this case, we're just getting one document back, and then we can get the content out of that, and you can get that in various forms. See, the top one is the JavaScript object, and the bottom one we've retrieved it as a string, which looks pretty similar in this case. Get things as buffers as well. There are other things, replace one if you want to replace a document, pretty easy to use. And just for the purposes of the next demo, I'm just inserting a bunch of other documents, just insert one, not bothering about the keys here. So inserted some random data, obviously could insert any kind of JSON structure, but use the same structure here. And then we get this query by example kind of syntax. So we're using the find operator again, filtering, we have a $like. There are regular expressions and all sorts of things, so just matching any document which had a name beginning with MA, and you can see Matilda and May have been returned. So rushing on heavily, another terminal count for documents, and then there's here's the reg example. So then in this case, removing anything which has an O in it from the address city field of the document and printing that. So we've started with 4 documents at the top here, drop 2, still have 2 left. And as purpose of the demo, we drop it so I can rerun it again if necessary. And that's it with Soda. There's a lot of documentation about that on our documentation site and generic Soda documentation site. We're starting to see a lot of interesting applications being created with it, and obviously with JSON directly if you're interested in the JSON SQL stuff that Sharad showed before. So that's it for the demos. Let's have a look at the availability topic. Okay, high availability. So without high availability, what happens with your app? You kind of know all of this. You're going to get some hangs. Particularly, we see that with TCP timeouts. You're trying to create a connection, or you start an operation across a network service and that network drops out. You might be waiting some time for the TCP timeout error message to come back through to the application stack. And obviously, without high availability, there are going to be connections. So you have to do a lot more coding in your application. And perhaps one of the worst things is duplicate transactions. That's kind of tricky if you start deleting money from people's bank accounts twice. Now, we have a number of solutions in the Oracle world. The benefits of our solutions are that we can do some of this stuff automatically for you, particularly in the cases that we divide these into the planned maintenance and the unplanned outages. The database node goes down or the network goes down. We can reduce or eliminate your need to write any kind of application code. So looking at CX Oracle itself, there are kind of a couple of tips here. The first one is always to use a connection pool. There are many benefits to this. Sharad mentioned some before, that it supports the DRCP and the application continuity that I get to. Also has those performance benefits that we mentioned before. Obviously, if you're in a single user, you may not be using a session pool, but you just have to be aware of the pros and the cons there. Now, there are a bunch of options that you can use. I've just chosen to highlight a few here. So these are OracleMania options. The top couple, the connection rate limit. So that means when you're creating that pipe across the database, if you remember Sharad's diagrams way back, the pipe from the Python to the database, that means that those pipes are going to be created at the rate which will flood the database. You can limit the number of processes which need to be created on the database side, particularly if you're starting up, say, a pool after a restart. Obviously, you have to create those connections, and you can limit the rate that the database has to work to create those. Middle set SQLnet parameters, bound connect timeout, really useful. I tend to run with this all the time. It means if you're trying to create that pipe again across the database and there is some delay, if I'm using a VM, for example, and the VM's not started, then I'm going to get an error back much sooner. Receive timeout, send timeout are great for runtime applications, but they have to be aware that they affect everything in the application. And these two affect packets being sent from the Oracle client libraries across to the database. And they say, if I haven't seen anything for a certain amount of time, I'm just going to cancel everything and return an error to the application. Expire time, actually, Sharad pointed out before. This is useful if you've got something like a firewall, which is killing connections. And obviously, those connections would then have to be recreated. Expire time will send a kind of probe packet across the network to make sure that the firewall thinks that the network connection is still in use. We've seen this, for example, with Azure when people are running applications in Azure connecting to Oracle Cloud databases. And Azure firewall used to, probably still does, time out things after about 4 minutes. And so you would set expire time there to 2 minutes, about half the amount of time. A lot of these things I've mentioned can now be set in that Easy Connect Plus syntax. Sharad pointed out about that before, thought it was worthwhile pointing that out. So you don't need to have these configuration files anymore if you're using this new syntax. And one other thing which actually kind of gets rid of those SQLnet receive timeouts is in the CX Oracle code itself, we have a call timeout attribute. And this gives you much more control. So you can set this at various points in the application and reset it. And you can take advantage of this to make sure that the database will return an error to you if its call is taking a long time to return. So those are some of the things which I used to call kind of easy high availability. The things you can do on the application tier, you don't have to speak to the DBA particularly about them, except obviously the rate limit stuff, but a lot of the other stuff is very easy to set up. But some of the other things are actually perhaps just as easy. You've heard some of these buzzwords, RAC and DG and things like that, TAF and FAN. Going to be talking a little about application continuity and TAC, the transparent application continuity themselves. And in many senses, these are as easy because you just set them up with a server setting on the database side, and you don't have to worry about it, particularly on the application side. It just works. So it's as simple as the others, but obviously it needs you to understand how it works, and the database administrator set up the service on the network's level. So what is it? Probably read by now, records the kind of work done, the calls that those Oracle client libraries make across the network. Obviously, Python's calling down to your Oracle client and the client's talking to the database. And it kind of records that work so it can replay it if the database node goes down. Available for some time, obviously getting better, we're enhancing it all the time. It's certainly making it easier and giving you more and more coverage with each version of Oracle database. So that's a very important feature for us. It's available in autonomous database, on-premises databases, etc. It does require that you have one of those standby databases like RAC or DataGuard there to actually replay this kind of work if the database node goes down. So set up and mentioned service attributes, so transaction level for application continuity, bunch of other service attributes that you can set there, failover retries, how often do you want to reattempt replaying this work. In fact, although I've listed them here, I think the best practice is recommendations to actually put those in the connect string so that you have more control over it. And you have extra settings. You can see there in U21C, we got this restate setting. You can decide how much session state, and we spoke about session state from the application tier before. You can decide how much session state you want AC to automatically recover for you so that your transactions can be replayed. So how does it work? There are really two phases. First one, as you can see, is the sort of normal case, counting down on the left. When you're using your connection pool, kind of what we call a starter request. When you get the connection from the connection pool, you do some work, and those Oracle client libraries are capturing those calls, the data which is flowing backwards and forwards, and some extra validation metadata. And if everything's successful, we just throw away those calls. We don't need to do anything. Your data's printed on the screen for users or inserted in the database, depending which way you're going. But what happens if there's a failure? Whoops, then we have to do some kind of replay. So there's some extra checking which goes on. We can't capture all things, so maybe the replay wasn't actually enabled. Maybe some things not supported yet, so you have to check what we are able to replay. Actually have to create a new connection, number 2 step there in the middle, create the new connection to the database, and this is all happening internally for you. You don't have to do this in your application. Client verifies was there some time, there's a timeout parameter you can set to make sure we're not trying to redo things which are really, really old. Again, database has to check whether things are valid on its side. And if there was partial work pushing into the database, we have to do a rollback as well. And at that point, step 6 on the right-hand side, we can start replaying all those captured calls and do some cross-check validation to make sure that everything was okay. And on success, client libraries return control to the application. So from the application point of view, everything was as it was. The application didn't know anything at all happened. Maybe a slight time delay, obviously, as we're kind of creating a new connection and replaying some work and doing the cross-checking. But something failed internally, and it was recovered internally without the application being aware of any problem. There are some restrictions. I mentioned that these are being reduced or improving things all the time. So just check your database manual to see what the latest is. Some unsupported calls like objects and advanced queuing. There was one thing which you may know in the C world, we used to have a limit on the number of calls which we could record, that amount of work that we could record. And for some reason, the C stack had a lower limit than the Java stack. So people in those environments were kind of wondering about that. That has been updated. I think it was the 19.11 or 19.12 has the updates for that. So we've got a huge number now of like 10,000 queries and things up from like 500, and there's different limits for other operations as well. So I don't think you'll see those issues that some of you might have experienced before. And that's the things which stop the replay capture. Replay also then fails if there was the timeouts on the right, or if there's some extra things we call these mutable functions, things like sysdate or sequence numbers and things like that. So if there was something which came back, we do give you some controls. Maybe you don't care about the sequence number, it's just a unique number. You don't care whether it's on the replay, whether it's the same as the original one, but maybe dates you do care. So there's some extra controls there. So there was a variant introduced in 18C called transparent application continuity, same sort of service setting, just a different kind of failover type, so auto here. It's a little perhaps more conservative. It tries to restore more of the session state. So it tries to automate some of the tasks that application continuity purely, the older application continuity can't handle. The real difference, if you want to think about it, is this recognition of what we call a request boundary, where when you're starting work, when you're stopping work, what do we need to record, what do we need to replay? And application continuity, as I showed in the previous slides, you really need to be using the Oracle connection pool. But if the session pool, as we call it in CX Oracle, but if you're not using that in an application, then you would be looking at using transparent application continuity, and we start recognizing where the request boundaries are. We do some extra bits and pieces about those basic mutable usages, and we can recognize that things are replayable. So with CX Oracle, the takeaway points really are use a session pool, as I mentioned, use things like the order by and group by, because if you're trying to select a set of results, we need to check you're getting the same results when the replay happened that you got originally, so that we know that the next statement is going to be valid. And so you need an order by or group by in the queries. I know there's some work to see what we can do about that, but that's the current state. And in CX Oracle, we have these attributes, module and action. They've been around for some time. These are recording metadata, which get piggybacked across the database and recorded and beat all the tables and things like that. And I've jumped a little bit ahead there in the diagram animation, but we have an AC check coverage report tool. The team tells me you really want the 19.12 version, but it's been around for a version or so before that. Kind of replaces this older ORACheck script that we used to have. And it's like AWR, the workload repository. You enable it, so you have a PL SQL package to enable it. You run your workload, and then you disable it and get a report. And when you run your application, you don't need to simulate errors. We'll look at the code and tell you what coverage is. You can kind of see that report on the bottom right. It's a little bit small, but it kind of tells you how much time each action and module kind of had as coverage, where it's going to be covered if there was a failure in that particular time. Maybe there's a particular amount of time where it wasn't going to be covered. And there's some things about which calls are and aren't covered. So you can use these tools to analyze how much insurance you're getting. So I guess this is really what they call the insurance for application continuity. So you have the insurance document to say, what am I getting? What am I not going to get out of this? Obviously, we're giving you a lot of this stuff, which just works and means that you don't have to worry about it in the back end. It's going to be a lot better than not having it at all. And it's going to cover many, many cases, and we're improving it all the time as well. So that's it for this talk. Time is always short. We'd like to have talked about a lot more. I'd like to thank Sharad for all of his preparation and work in this presentation. And you can contact us at any time that you like, Twitter, Slack, GitHub, all sorts of places are accessible. But please, one thing, do contact us and let us know what you're doing with CX Oracle. And we know that a lot of you out there, we're always being asked, who is using it, why are they using it, what do we need to improve, how much, resources do we need to allocate as a company to CX Oracle? And without knowing what you're doing, it's very hard for us to justify with just that single, although very large download number. But thank you very much for your time today. I hope you have a good conference. We have another session coming up on Python. Look at the agenda for that, and hope to see you there for that session. Thank you, Sharad. Thank you, everyone. Bye-bye.
Thank you.
CloudDB, shaping your new normal.